video, we are going to explain about a project titled Static and Dynamic Malware Analysis using Machine Learning. So here coming to the introduction part, static and dynamic malware analysis serves as a crucial line of defense against the growing array of malware threats. The integration of machine learning elevates the capabilities of these analysis methods, revolutionizing how malware is detected, analyzed, and countered. By harnessing the power of automation, pattern recognition, and adaptability, the synergy of machine learning and malware analysis holds promise for a more resilient and secure digital environment. With machine learning, dynamic analysis becomes more adept at differentiating between normal and malicious behavior as algorithms can process vast amounts of data generated during execution, leading to more accurate threat identification. So now coming to the objective part for this project, to incorporating machine learning into static and dynamic malware analysis is to fortify the capabilities of cybersecurity professionals in identifying and combating evolving malware threats. Through improved accuracy, automation, adaptability, and a comprehensive approach, this integration aims to enhance our ability to defend against a wide array of malicious software and maintain the security of digital systems and data. Machine learning can automate the analysis process, leading to quicker and more efficient identification of malware. This is particularly crucial given the rapid pace at which new malware variants are developed and deployed. By automating routine tasks, analysts can focus their efforts on more complex and strategic aspects of cybersecurity. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first upload Cuckoo malware log dataset. The first step is to upload the Cuckoo malware log dataset, which contains data collected during the analysis of various malware samples using the Cuckoo sandbox. This dataset includes information about both dynamic and static analysis of malware, including the behavioral indicators, API calls, file changes, and other relevant attributes. Second, generate train and test model. Once the dataset is uploaded, the next action is to generate a train and test model. This involves splitting the dataset into two parts, one for training the machine learning model and the other for testing its performance. Third, dynamic malware analysis. Dynamic malware analysis involves analyzing the behavior of malware in a controlled environment, often referred to as a sandbox. During dynamic analysis, the malware is executed and its actions, such as file modifications, network connections, and system interactions, are monitored and recorded. Fourth, static malware analysis. Static malware analysis focuses on examining the attributes of a malware sample without executing it. This includes analyzing its code, file structure, and metadata. Static analysis can reveal signatures, strings, and patterns indicative of malware intent. Fifth, AUC comparison graph. After conducting both dynamic and static analysis, the AUC here stands for area under the curve comparison graph is generated. The AUC metric measures the performance of the machine learning model in terms of its adaptability, ability to correctly classify malware and non-malware samples. Sixth, close application. The final step in the sequence of actions is to close the application. After completing the necessary analysis and generating relevant comparisons, the user can choose to exit the tool and conclude the process. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. So now in this folder we are containing some dataset over here in the .csv file. And here this is the malware file, this is the Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload Cuckoo malware log dataset button to upload the dataset. Here I am selecting malware dataset button and now click on open button to load the dataset. So here on this screen you can see that the dataset has been loaded over here. And now click on generate train and test model to read dataset and to find total rows and columns available in the dataset. And we can see that here the data set has been split into 80 and 20%. 80% data set will be used for training, that is 10868, and 20% for testing. So here we have got the column says 102 over here. So now we have to click on dynamic malware analysis button to build or classify on dynamic features to calculate malware prediction AUC value. So now here on this screen for all 5 classifiers we got AUC values and true positive and false positive. Here true positive means application correctly predicted given test recorded as malware, and false positive means application incorrectly predicted. So here we got AUC value as 50% for all classifiers as the data set size is huge, and we set high parameters to classifier, then computer will hang. And to get better AUC we need to set high parameters to classifier, but to do that we need high configuration system. Normal laptop can run classifier but may take huge time to run each classifier. Due to that reason I am not using classifiers with heavy parameters or iterations. So now click on static malware analysis button to build classifier with static features. So now here on this screen we got AUC values with static features also, and now click on AUC comparison graph button to get the comparison graph. So here in this graph you can see that 5 classifiers, here x-axis represents 5 classifiers from 0 to 4, and here y-axis represents AUC score of each classifier. Here y-axis represents AUC score. Classifier with high AUC will be considered best. And in this graph, blue lines for static and orange line for dynamic. From this graph we can conclude that all classifiers give little better AUC for static malware detection compared to dynamic. So now closing this graph, and by clicking on the close application button we will exit with this application over here. So now coming back to the conclusion part, in essence the convergence of machine learning with static and dynamic malware analysis is a pivotal step toward achieving a more resilient and proactive cybersecurity framework. As cyber threats continue to evolve in complexity and scale, our defenses must evolve in tandem. By embracing the power of machine learning, we are equipping ourselves with a formidable arsenal to tackle these challenges head-on, fortifying a digital infrastructure and ensuring a safer and more secure digital future. As the proliferation of malware variants continues, automatic routine tasks enable cybersecurity experts to focus their expertise on strategic decision making and addressing emerging threats. Time is the essence in the realm of cybersecurity, and the accelerated analysis provided by machine learning contributes significantly to our ability to respond swiftly to evolving attack vectors.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.